Kinematics, linear motion, UTME Physics, past question 1983 to 2000. Question 15 of 1983. We have a train has an initial velocity of 44 meters per second and an acceleration of -4 meters per second square. Its velocity after 10 seconds is, so in physics what we like to do is always write the data first. So initial velocity u is 44 meters per second and an acceleration is -4 meters per second squares, which implies that this body is decelerating. Now its velocity, we're looking for its velocity after 10 seconds. So I'm pretty sure you all know the equation we'll use v equal to u plus 8c, and we will be having v equal to u is 44, then we have plus -4 times the time is 10, so we will be having 44 minus 40, which will be equal to 4 meters per second. So our answer is option B. Next question, UTME 1984, question number 1. The distance traveled by a particle starting from rest is plotted against the square of the time elapsed from the commencement of motion. The resulting graph is linear. The slope of this graph is a measure of. Now, if you think about it, we're told that the distance traveled by a particle starting from rest. So, the distance s, the particle starting from rest u equal to 0, is plotted against the square of the time elapsed. So it's plotted against square of the time elapsed. Now, that implies that if we have my axis, if I have my vertical axis x plotted against the horizontal axis t square. Now for the equation connecting these two guys, it's going to be this one, which is s equal to ut plus 1/2 at square. We have that, and u is equal to 0. So anyway, let's just wait for that. The resulting graph is linear. Now, since the resulting graph is linear, okay, we know that u is equal to 0. That is the body starting from rest. So s will be equal to 1/2 at square. Now, if you think about it, if we relate this to the normal equation of a straight line, since you are told that the resulting graph is linear, so y equal to mx plus c. Now, we know that c implies that that's the intercept on the y-axis. C is the intercept on the y-axis. So if we have, since we're told that the body is starting from west, so the body is starting from west, so somewhere around there we have here. So the body is starting from west, and the graph is linear, where it depends on, since the graph is linear, we're pretty sure we will be having something like this. Definitely, that is what we will be having. And since c will be equal to 0, just like in this case u is equal to 0, that means y will be equal to mc. So if you say y is equal to mx, sorry, not mc, you are plotting y against x, that means you are plotting s against t square. So the gradient, which is m, will represent the gradient here, which will be the coefficient of t square. In this case, that is 1/2 a, and that will represent half the acceleration, which is option D. UTME 1985, question number 6. If a car starts from west and moves with a uniform acceleration of 10 meters per second square for 10 seconds, the distance it covered in the last 1 second of the motion is. Now, let's think about it. if a car starts from west, u is equal to 0 and moves with uniform acceleration of a equal to 10 meter per second square for 10 seconds. Now for 10 seconds, we have that the distance it covered in the last 1 second of the motion. Now if you think about it, in the last 1 second means the distance it covered in the 10th second, because the total time is 10 seconds. So in the 10th seconds, in the 10th, let me say that would be t sub 10. In the 10 seconds, that is what this means. So how do we get that? That implies that the distance it covers for a total time of 10 seconds minus the distance it covers for a total time of 9 seconds will be the distance in the 10 seconds, which another way of saying that is last 1 second. So we just need to figure this out, then subtract this from this. So we'll be having x sub 10 will be equal to 1/2 8c squared, since g is equal to 0. So that will be 1/2 times 10 times t squared, that is 10 squared, and that will be equal to 1/2 times 1000, which will be 500. So we've got 500 meters for the distance it covers in 10 seconds. Now we need to get the distance it covers in 9 seconds. Now the distance it covers in or for 9 seconds will be 1/2 a, that will be 10, then times t, that will be 9 square. So we will be having 1/2 of this, that will be 5 times 81. And what is 5 times 81? 5 times 81 is 405. So we have 405 meters. So the distance covered in the last 1 second is going to be 500 minus 405, and I'm pretty sure you know that will result in 95 meters, which is option A. UTME 97 question number 3. We have the velocity time graph above describes the motion of a particle between 2 points P and Q. What is the distance between P and Q? This is the motion that describes, the graph that describes the motion of the particle between 2 points. You've got point P. I'm pretty sure, of course, this will have to be point P, starting from here, then to a position of Q. Since this Q is here, I'm sure this Q will be somewhere around here, because if it's here, if it's up to this point, that means the graph is meant to go all the way to this point. So I'm pretty sure this must have been due to some irregularity in the graphics of this stuff. So the velocity time graph above, describes the motion of a particle between 2 points P and Q. What is the distance between PQ? Now for a velocity time graph, for us to get the distance covered between 2 points, we usually get the area under the graph to get the total distance covered whenever we have a velocity time graph. So if you look at this graph, let me kind of align it out here. Let me align it out. We've got this. Now we also have this. We have this. We have this. I'm pretty sure it's all the way here. Now this graph, it's not a regular shape, but it consists of separate regular shape, because if you look at this, the first one here is a triangle. We've got a triangle right here, a right angle triangle to be precise, and we've got another regular shape in here, which is a trapezium. We've got another one here, which is a rectangle, and we have another one here which is a triangle. Now so for us to get the area of this total shape, is going to be the area of this triangle with the area of this trapezium. So let me just call this shape A, shape B, shape C, and shape D. So just some of the areas, then you have that. So for shape A, the area is going to be 1/2 base times height times the base is 1, the height is 4, so that is 4 meters. That is sorted. Then for B is a trapezium, so it's going to be 1/2 sum of the two parallel sides. The first parallel one is 4, we have 4 plus the other parallel side is 6. From here to here, that is 6, then times the height. The height in this case is going to be 1, the difference between this and this, which is going to be 1. So we will be having 10 divided by 2, 5 times 1, that is going to be 5 meters. So we have 5 meters. Now for C is a rectangle, so that is just going to be from here to here, which is going to be the height is 6, so for C that will be length times breadth. The length is 6, 6 times the breadth. The breadth is going to be we know this is going to be 3.5, so from here to here the difference is going to be 1.5, so times 1.5, so we have 6 times 1.5, which is going to be 9 meters. Then D is a trapezium, so we will have 1/2 times some of the two parallel sides. The two parallel sides in this case, this side and this side. I'm kind of getting to stay somehow. So I have this side and this side. So I have 6 plus from here to here, that is 2. Then the height from here to here, that is 0.5. 4 minus 2.5, that is 0.5. So we will be having 1/2 times this is 8, then times this is also 1/2. So 1/2 of this, that is 4 times 1/2, that is 2. So we have 2 meters. So all we just gotta do is sum these guys up. So this plus this, that is 11 plus 5, that is 16 plus 4, that is 20, which I hope I'm not making any mistake here, because if I check everything to be correct, so let me go through all this one more time. I have 1/2 times 1, which is 1/2, then times 4. Oh yeah, here's the issue. 1/2 times 4, that is gonna be 2, not 4. 2 meters. I didn't know what I was thinking then. So I have 2 plus these, that is 7 plus 9, that's 16 plus this, that is 18. So the total area is 18 meters, which is option B. So we're done with that. The next one is 1988, question number 6. A particle starts from rest and moves with a constant acceleration of 0.5 meter per second square. The distance covered by the particle in 10 seconds is, so the particle starts from rest, u equal to 0, and moves with a constant acceleration of 0.5 meters per second square. The distance covered, that's what we're looking for, in 10 seconds. So think about this. I'm pretty sure what should pop out to your mind is this equation right here. This equation right here is S equal to U, that's going to be 1/2 AT squared. S will be equal to 1/2 times 0.5 times 10 to the 2. So we will be having 1/2 times 1/2 times 100. So 1/2 of 100, that's 50. 50 times 1/2, that is going to be 25 meters, which will be option C. And the next one is that same year, question number 9. The figures above show the displacement time graph for 3 different motions. Which of the following statement is correct? Graph 2 corresponds to the ice velocity. Nope. Graph 2 shows that the velocity is constant. Graph 1 corresponds to 0 velocity. Yes, this is correct because the displacement is constant. Graph 1 corresponds to 0 velocity because this is displacement time graph, and velocity is equal to change in displacement per unit time. And since the displacement is not changing, it's 0, it's constant. That implies that 0 divided by t is going to be 0, so the velocity is 0. UTME 1989 question number 3. 2 points on a velocity time graph have coordinates 5 seconds 10 meters per second and 20 seconds 20 meters per second. Calculate the mean acceleration between the 2 points. Okay, so think about it. We have a velocity time graph. A velocity time graph, v in meter per second, and we have t in seconds. So for the first guy, we have 5 seconds. For 5 seconds, it corresponds to a velocity of 10 meters per second. And for 20 seconds correspond to 20 meters per second. So if we want to get the mean acceleration, of course, what we have to do is to connect these 2 points. What is mean acceleration? Average acceleration is equal to the increase in velocity. In other words, the change in velocity over the time interval. So for the change in velocity, that's going to be 20 minus 10, which is 10, divided by 20 minus 5, which is 15. And 10 divided by 15 is equal to 0.666, which is approximately 0.67 to 1 decimal place. If we take it to 1 decimal place, so that would be if we take it to 2 decimal place, so the next guy here, that's going to be 0.67 meter per second square, which is option A. Question number 5 of the same year. Which of the following graphs represents motion with uniform velocity? And if you think about it, we can only deduce, well, most of the time we deduce velocity from displacement time graph. So for displacement time graph, we will have something like this, either this or this. Now, as I said earlier, the displacement here is constant, so it implies that the velocity is 0. And here, once there's a straight line, it shows that that is a constant velocity or a uniform velocity. So our answer is option B. Now, we can, just like I said earlier too, we can also get the uniform velocity from a velocity time graph, but that implies that the velocity will be constant. So in that case, if we were to see a velocity time graph, that implies that if this is velocity and this is time, that means that you have something like this. So if the question comes in form of a velocity time graph only, and you are told to interpret the graph so that you will be having a uniform velocity, then definitely you'll be having something like this. So, but for this question, our correct answer is option B. The next one, we have UTME 1990 question number 4. A car moving with a speed of 90 kilometers per hour was brought uniformly to rest by the application of the brakes in 10 seconds. How far did the car travel after the brakes were applied? The brakes were applied. So a car moving with a velocity of this, so we have u is 90 kilometers per hour, was brought uniformly to rest, so the final velocity is equal to 0 by the application of brakes, and it took 10 seconds to bring about this change. How far did the car travel after the brakes were applied? So we are looking for S, and the equation that connects these 1, 2, 3 for these four guys together is this: S equal to U plus V divided by 2 brackets T. First thing first, we need to convert this guy to meters per second, and that is going to be equal to U equal 90 times 1000, as 100 meters makes a kilometer, divided by 3600, and as 3600 seconds makes an hour. So we will be having this guy cancel this guy, and we will be having 900 divided by 36, and I don't want to disturb my head, so let me just make use of my calculator right here. So I will be having 900 divided by 36, so that is also 25. So this guy is off, so I have 25. That'll be equal to 25 meters per second. And okay, so I can now substitute. S will be equal to 25 plus V, 0 divided by 2 times 10. Then I will be having 25 times 10, which will be 250 divided by 2, and 2 divided by 2, that will be 125 meters, which will be option A. Now, that same year, question number 6, we are told what is the average velocity of this sprinter whose velocity time graph is shown in the figure. So if we want to get the average velocity of this guy right here, of course, okay, first and foremost, you ask yourself, what is average velocity? Average velocity is displacement, or change in displacement per unit time. I think I've been saying change in displacement. I think technically it's change in position per unit time, that is average velocity. So you can just say displacement per unit time. Sorry about that. It's displacement per unit time. You can just think of it as change in position per unit time. So that's for that. So now in this case, if you think about it, since the motion is pretty much in one direction, as you can see, the graph is above the x-axis, so that implies that it is in one direction. So the displacement and the distance will be the same thing. So for us to get the distance will be the area under the graph. So once we get that, we'll divide it by time, and then we can figure out our velocity. So displacement is going to be area times area of the graph, which is going to be 1/2 times, since this is a trapezium, 1/2 sum of the two parallel sides. The longer one is 10, so we have 10 plus, from year to year, that would be 6 times the height, that's from year to year, which is 10. So I have 10. So I have 16 divided by 2 times 10. This 3 and 1 2 here is 8. So this times this, that would be 80 meters. So I've got that 80 meters. That one is done and dusted. So the other one is the time. So the average velocity is going to be the displacement. The displacement is 80 divided by the time is 10. So that would be 8 meters per second. And if I look through this options, there's no 8 meters per second square. So what I would do one more time is to go through this again, and if I go through this 1/2 brackets 10 plus 6 times 10, yes, these times these, yeah, shows that everything is pretty much all right. So just like you must have seen in my previous videos, there are sometimes you won't find the question in the you won't find the answer in the question. So please, if you're an examiner, just don't uncheck anything. Just leave, whether it's radio button or checkbox, whichever computer interface you are given on that day for your CBT, just leave it unchecked and move to the next one. As far as you sure all your calculations and manipulations are right, then you are good to go. So in this case, there is no answer, so leave it unchecked. Now the next one is UTME 1992 question number 4. Your body starts from rest, so U is equal to 0 and moves with uniform acceleration for 6 meters per second square. What distance does it cover in the 30 seconds? I'm pretty sure we'll solve something similar to this, which is I can't quite remember whether it's the UMA or the, but anyway, you get the point. So what distance does it cover in the 30 seconds? So the distance it covers in 30 seconds, that is gonna be the distance, the 30 second. In this case, let me just put T to show that the 30 second. So that's going to be distance in covers for 3 seconds minus distance is covered for 2 seconds. We give you the distance covers in the 30 seconds. So so that's going to be S equal to 1/2, since U is equal to 0. So we just have 1/2 AT square. So distance covered in 3 seconds, that is going to be 1/2 times A is what? A 6 times T square, that will be 3 square, and we will be having here, that will be 3, and we'll be having 27. So 9 times 3 is 27, and for T sub 2, that is going to be 1/2 times 6 times 2 square, which will be 3 times 4, and that will be equal to 12. So 27 minus 12 will be equal to 15. So that will be 15 meters, which is option A. The next one, UTME 1993 question number 3. The diagram above shows a velocity time graph representing the motion of a car. Find the total distance covered during the acceleration and the retardation periods of the motion. Now, you've got very careful here. You are told to find the total distance covered during the acceleration. During the acceleration, this is the period when it was accelerating, and the retardation period, not the total distance covered. No, for the journey. The total distance covered for the journey is going to be the area under the graph, the whole graph, but it's just the acceleration and the retardation period. So the distance covered during the acceleration period is gonna be area under the area of the triangle. So that's gonna be 1/2 times the base 10 times the height 10, and 10 times 10, that's 100 divided by 2. Of course, that is gonna be 50. So we've got 50 meters during the deceleration period or the retardation period. We've also got 1/2 times the base. Now I'm not quite sure if this looks like it's falling at the middle, but of course I'm pretty sure that's an intuitive way of thinking about it, that it's gonna fall at the middle. So this will be 45. So 45, this from here to here, that will be 5 times 10. So I'll be having 2 in here, 1, 2 in here is 5. 5 times 5, that is 25. So I have 25 meters. 50 plus 25, Since we are told to find total distance, that will be 75, which is option A. Then UTME 1994 question number 5. We are told a motor vehicle is brought to rest from a speed of 15 meters per second in 20 seconds. Calculate the retardation. So the retardation, of course, deceleration is going to be the initial minus final divided by 2. Or you could do it the other way. It's going to come out negative. So the initial is 15 minus is brought to rest divided by 20. So we will be having 15 divided by 20, and let me get my calculator out for that. So 15 divided by 20, not just in the mood to think today, that would be 0.75. That would be 0.75 meters per second. So that is option A for that. And UTME 1995 question number 6. The velocity time graph of a body moving in a straight line and decelerating uniformly to rest is represented by, now, a body moving in a straight line. Remember that if you look at the thumbnail of this video, it's linear motion, kinematics. Now we're talking about linear motion. That means motion in a straight line. So don't let this confuse you. It's just what this whole topic is about, motion in a straight line. Now the velocity time graph, okay, decelerating uniformly. Now if it is decelerating uniformly, then you know that the answer is option C, because it is decelerating uniformly. That implies that the velocity is decreasing. Here the velocity is increasing uniformly, but here the velocity is decreasing uniformly, which shows that the acceleration is constant. So the acceleration is constant for both of them, but it's just that the velocity, it is the acceleration here, it is deceleration actually. Here it is decelerating, while here it is actually accelerating. So the acceleration here is constant, while the deceleration here is constant. And there are so many ways you can think about it. The whole idea of accelerating uniformly or decelerating uniformly is that, oh, the acceleration is constant. So we have UTME 1997 question number 2. The distance x meters traveled by particles in time 2 seconds is described by the equation x equals to 10 plus 12t squared. Find the average speed of the particle between the time interval t 2 seconds and t 5 seconds. So if you think about this, we're looking for the average speed. So and whenever we're looking for average speed, we usually deduce it from a distance time graph. So a distance in meters and time in seconds. So for t 2 seconds, you just substitute right here. You'll be having 2 squared, that is 4. Then you'll be having 4 times 12 plus 10. And 4 times 12 is 48. 48 plus 10, that is 58. So when it's 58 distance from wherever it's coming from in 2 seconds, 58 meters. Now at a distance of 5 seconds, sorry, the distance which the body will be at the time of 5 seconds will be 25. That is 5 squared, 25. So we will be having 25 times 12, which will be 300. Then we'll have 300 plus 10, that will be 310. So we've got 310 meters. Now for us to get the average velocity, of course, the average velocity, if you think about it, if we have this guy here, we just have to look for the difference in the of course, the distance, because you are told between the time interval, so you need the distance covered within the time interval, which is going to be the difference between these guys over the difference between these guys. Therefore, the average speed is going to be 310 minus 58, which will be 252 divided by 3. So 252 divided by 3 of 3 in 25, that will be in 24, which is going to be 8. Then in this, that will be 84. So we will be having 84 meters per second. Option C. The next question, we've got UTME 1999 question number 7, and the diagram above shows the velocity time graph of a vehicle, its acceleration and retardation respectively. We need the acceleration for this guy. The acceleration for this guy is going to be change in velocity 80 divided by 20, which will be 4 meters per second square. Then the retardation will be change in the velocity, that will be 80 divided by the time it took for that change, and that will be 90 minus this, which will be 40, and that will be 2 meters per second square. So we will be having 4 and 2, which will be option C. The next question, UTME 2000 question number 8. The velocity v of a particle in a time t is given by the equation v equal to 10 plus 2t squared. Find the instantaneous acceleration after 5 seconds. Now, for instantaneous acceleration, I believe we know that we can figure that out. No, that's not the only way. Of course, if you have a graph, there's a way you can do that. But for when you're given an equation, you can figure that out by making use of differential calculus. So our acceleration, instantaneous acceleration, is always dv dt. So v is equal to 10 plus 2t squared, and dv dt will be equal to the differentiation of a constant 0, so I have 0 plus 2 times 2, 4t. You subtract 1 here, that will be raised to the 1, so that will be 40. So that will be 40. Then what do? You substitute for the t when it's 5 seconds, so that will be 4 times 5, and that will be equal to 20, which is option C. So oh yeah, that's the end of this video. Your tutor SB Sanni. You can follow me on Twitter, and you can also check out our website www.sbelucidation.com. I'll leave a link in the description below. From there you can download past questions for Jamb or WAEC free of charge, and with time I'm still coming up with more and more past questions, so watch out for more. See ya, take care.